which we understood it first. What do we mean by a curvature? Then let us consider there are be two curves. First curve, say AB, and second curve, let us say CD. In general, what are difference seeing in the curves AB and CD? We say that AB is more bending compared to CD. It means geometrically what we can say difference between AB and CD is expressed by saying that the curvature of AB is greater than that of CD. Means a curve have more bend, has more curvature. Let us say a point P, and if we on here and also a point P here, if we make a circle, what will be, and here also make a circle in neighborhood of P, then this curve has what? A point P and circling on it have lesser radius. Lesser radius means more curvature, and this curve at this point of circling have some greater radius compared to circling of AB. Then it has lesser radius compared to circling at curve AB. Now we have this it by writing. What do we mean? In this case, the geometrical difference between M and CD, the geometrical difference between AB and CD is expressed by saying that the curvature of AB is greater than that of CD. If in the second way, if a small arc in the neighborhood of P P on the curve P on the curve is AB and CD is regarded as circular, then it is quite clear that radius of the circling at point P on AB is lesser than that on CD on CD. That is greater the curvature lesser the radius and vice versa. This forms the basis of curvature. Basis of curvature. Now we have give some definition. Let AB be a curve and P and Q are 2 points on AB that are neighboring point on the curve AB. Let the norms drawn at the point P and Q are intersect to each other at the point N as shown in figure. This is a B curve and this be a point P and this is a point Q. Then let there will be a tangent on P and a tangent on Q. There will be a normal on P and also a normal on Q, and it intersected a point N. There will be a point C where as Q tends to P, then N tends to C. If N tends to a definite point C as Q tends to P, then the point C is called center of curvature. At the point P on the curve AB, the length CP is called radius of curvature. Radius of curvature of the curve at P, of the curve at point P, and is denoted by a Greek letter rho. The spoken of the distance Cp, the spoken of the distance Cp, that is 1 upon Cp, that is 1 upon O, is called the curvature of the curve, is called the curvature of the curve at P. Now we find a circling and discuss about the what is circling of curvature. This circling with C, a circling with C as center and Cp as radius is called the circling of curvature. Called the circling of curvature of the curve at P. In this case, a card passing through P of the circling of curvature at P is called the card of curvature. Now we give some alternative definition of the curvature, and we have discussed about how to formulate curvature of a curve at the point P. Let us discuss another definition which is known as alternative definition of curvature. Alternative definition of curvature. Alternative definition of curvature. Let P and Q be two neighboring points. Be two neighboring points on the curve AB. Points on the curve AB. This is a curve AB and P and Q are 2 points. Let there be tangent P at P and there will be tangent at Q. Then there will be a normal, and here also a normal, and intersected end A, and this is point C. When Q tends to P, then N tends to C. Let us say this angle will be delta psi, then and make let us meet the point P and Q. What will be? This is and this is a triangle. Who, if it intersected, say, then R, then PQR is a triangle, and delta psi what work? Delta psi is a external angle. Then sum of angle P and Q. This sum of these two angles will be 180 minus delta psi. Therefore, this angle will be delta psi. This angle will be delta psi. Let us say then from the fixed point A, length of P will be, arc length of P will be S, and arc length of Q from A will be S point delta S, so it will be delta S. The arc length of PQ is equal to delta S. Then what will be delta psi is said to be angle of contingence of the arc PQ, and it is also called as total curvature of the arc PQ. And in this case, we take a fraction of, of delta psi upon delta s. It is called the average curvature of the arc PQ, and as Q tends to P means delta S tends to 0, then it will become that curvature at the point P, which now we let P and Q be two neighboring points on the curve AB. Let delta psi be the angle between tangents at the point P and Q on the curve AB. 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 Then delta psi is called angle of contingence of the arc PQ. It is also angle between normal at points P and Q on the curve AB. It is also called the total curvature of the arc PQ. It is also called the total curvature of arc PQ. And now we take a fraction, means the fraction, the angle of contingence upon length of arc. Angle of contingence upon length of arc is equal to delta psi upon delta S, is called the average curvature. Curvature of the arc PQ. It is also called average bending of the arc PQ. The limiting value of the average curvature of the average curvature of the average curvature of the curve at the point P of the curve at the point P when Q tends to P is called the curvature. Thus, curvature at the point P is equal to limit Q tends to P delta psi upon delta S. means limit delta s tend to 0, delta psi upon delta s d psi upon ds, and radius of curvature at the point P at the point P is equal to 1 upon curvature, which is equal to ds upon d psi is equal to rho. Now we have discussed about the formula for radius of curvature in intrinsic form. Means this formula which is given by definition is now derived as a formula. The formula for radius of curvature in integer is form. Formula for radius of curvature in intrinsic form. At first we define what is intrinsic form. The relation between s and psi is called intrinsic equation of the curve. Relation between s and psi is called the intrinsic equation of the curve. The formula rho is equal to ds upon d psi is used to find rho when the equation of the curve is given in intrinsic form. Now we derive this formula by geometrical. Again, go to back figure and see what we have. Now by previous diagram, we have angle P and Q is equal to delta psi. From triangle PQN by sine formula, we have Pn upon sine PQN is equal to card PQ upon sine delta psi, which implies that Pn is equal to card PQ upon sine delta psi into sine PQ, which is equal to card PQ upon delta S into delta S upon delta psi into delta psi upon sine delta psi into sine PQ M. If we say let rho be the radius of curvature at P, then rho is equal to limit Q tend to P, Pr, which implies that limit delta S tend to 0 curve PQ upon delta S upon delta psi, delta psi upon sine delta psi into sine PQ. Now what we will have, as Q delta S tend to 0, then cut PQ upon delta S is equal to 1, and delta S upon delta psi tend into ds upon d psi, and as Q tends to P, then PQ and angle is equal to pi by 2. It means 1 into ds upon d psi into 1 sine pi by 2, because this is delta psi tend to 0, this tend to 1. It implies that ds upon d psi. So rho is equal to ds upon d psi. This is radius of curvature. Now curvature is equal to 1 upon rho d psi upon ds. This will be definition. Now we want to give an example. Find the radius of curvature at the point S psi. Find the radius of curvature at the point S psi, means intrinsic form on the curve. Curve is given by S is equal to A log tan psi plus sec psi plus A tan psi into sec psi. Smooth. So we what find radius of curvature? Rho means ds upon d psi. We have rho S is equal to A log tan psi plus sec psi plus A tan psi into sec psi. Now we differentiate. Now differentiating with respect to psi, we have ds upon d psi is equal to A into 1 upon tan psi plus sec psi, and differentiation of tan psi is sec square psi, and differentiation of sec psi is sec psi into tan psi plus A, and differentiation of tan psi into sec psi, this is product. Differentiation of tan psi is equal to sec square psi into sec psi plus, and tan psi differentiation of sec psi is sec psi into tan psi. This will be required. what this means? This means here taken sec psi common, then a sec psi. Sec psi was tan psi. Sec psi was tan psi upon sec psi was tan psi was a sec psi taken as common, then a sec psi and sec square psi here tan square psi. Then what can be? It can be written as sec square psi, and tan square psi can be written as sec square psi minus 1 minus 1. What this is cancelling out sec psi must into sec psi. This means it will be a sec psi, and here what will be sec square psi sec square 2 sec square psi means 2a, and this will be sec q psi minus a sec psi. These are cancelling out, which imply that 2a sec q psi, 2a sec q psi ds upon d psi. This will be, what will be said? This is said to be rho radius of curvature. So curvature is 1 upon 2a sec q psi. Now we give some exercise on the basis of this. What will be, you need to find and doing this type of exercise. Search. So that the curve for which S is equal to under root 8ay, the circuit has its intrinsic equation S is equal to 4a sin psi. Hence prove that rho is equal to 4a under root 1 minus y upon 2a.